start. We have main engine start. 4, 3, 2, 1, 0, and liftoff. Liftoff of the space.
In our natural pursuit of knowledge, space has always mystified and beguiled us. Over the past 5 decades, we've pushed the final frontier inevitably onward into the ether. The cost has been colossal. Now every day, new data, new conclusions, and the thirst for deeper exploration propel us inexorably onward. The advantages of the discoveries made through space travel are myriad, but the fundamental curiosity as to what is out there will always fascinate and taunt us. Come with us now into the unknown and discover the disappearing frontier. In this edition of Disappearing Frontier, we go back to Project Mercury, a vital cog in the NASA machine for getting the USA back in the space race and putting a man on the moon. And we join the men and women who live the dream of becoming an astronaut. These modern-day space travelers are doing the things that we once could only read about in comic books. But it's a long, hard haul as we watch them reach for the stars. On October the 4th, 1957, the Soviet Union launches Sputnik 1, the first artificial satellite. The Soviets' launch is for the International Geophysical Year, or EGY. The geophysical year is 18 months from July 1957 to December 58. More than 70 nations and as many as 70,000 scientists cooperate to investigate the world and its environment. Sputnik 1 concerned America because of the far-reaching technical and military implications of the launch. Less than a month after the first Sputnik, Russia launched a second Sputnik, which weighed about ½ a ton and carried a dog as a passenger. This Sputnik caused even more concern for America because of the size of the satellite. During the IGY, the United States planned to launch a Vanguard satellite, which weighed just a little over 3 pounds. The attempt to launch the Vanguard on December 6, 1957, ended in failure in a ball of flame and wreckage. Following the disaster, a team including Dr. Werner von Braun from the Army's Redstone Arsenal were given their long-sought chance, the go-ahead to launch an American satellite. They used their flight-proven Jupiter C rocket launcher. At Cape Canaveral, in late January 1958, the coveted satellite, known as Explorer 1, is placed atop the Jupiter C, poised on Pad 26 for firing. Explorer 1 is to be about 30 pounds in orbit. Severe winds cause a 2-day postponement. Then on January the 31st, 1958, the United States answers the Soviet challenge in space. Explorer makes a major discovery, a radiation belt around the Earth. Dr. James Van Allen from the University of Iowa identifies the region. The finding of the Van Allen belt is an important finding of the International Geophysical Year. Until this time, much of the American effort in the development of aeronautical and spaceflight had been fragmented between a number of organizations. the Navy, Army, Air Force, the National Science Academy, and the National Advisory Committee for Aeronautics. These were now brought together under the umbrella of the National Aeronautical and Space Administration, NASA. A major priority of the new administration, the first US manned spaceflight program, Project Mercury. Scientists developed the Mercury capsule shape through tests. Engineers conducted wind tunnel tests with small and large-scale models, covering speeds from 0 to 18,000 miles per hour. Researchers fire small models of the capsule in the supersonic free-flight ballistic gun range. The gun sends the 1-inch model down a 30-foot instrumented range of recording stations. The model travels at 10,000 miles per hour. As the model speeds down the gun range barrel, photographs and shadowgraphs are taken. This shadowgraph shows airflow around the model. Workers develop boilerplate versions of the Mercury capsules for tests. The first test is a parachute drop test from an Air Force C-130. The capsule slides out of the plane's cargo door on a sled. The sled releases. A charge ejects a drogue parachute. The United States went on to try 37 satellite launches by December 1959. Less than a third are successful. As a result, NASA begins to instill a new sense of rigid quality control to check and check again everything: rocket components, wells, valves, pumps, materials, and so on. Over time, the quality control program works. Early in 1959, NASA selects a team of 7 engineer pilots for Project Mercury: M. Scott Carpenter, L. Gordon Cooper, John Glenn, Virgil Grissom, Walter Schirra, Alan Shepard, and Donald Slayton. Preparations for flight are unusual. After 2 hours, the astronaut is lifted from a mold used to make a flight couch to fit his body shape. In the early days, veteran test pilots looked down on the role of pilots for Project Mercury, but the Mercury pilot was playing an active role. He was controlling the capsule's attitude and pitch, roll and yaw, as well as controlling the navigation and communication systems. In all Mercury flights, the pilot proved essential to the success of the mission. He operated all the primary flight controls and initiated the firing of the retro rockets, beginning the descent to a landing. Spinning in a centrifuge cab, astronauts learnt important lessons as to how to react to the G-loads of emergency aborts. Meanwhile, technicians tested an escape system for an early Mercury capsule. The pilot must be able to escape from the Mercury launch site in case of an emergency. In this unmanned test, a 16-foot tower with a solid rocket sends the capsule safely away. During this test, a rhesus monkey is aboard. At more than 1,300 miles per hour, pressure-sensing devices start the escape. Eventually, a successful recovery. Extensive Mercury program research and development continues. Workers launch a Big Joe Mercury test capsule almost into orbit to test re-entry into the Earth's atmosphere. An Atlas booster carries the capsule to an altitude of 100 miles and nearly to orbital speed. From the recovery ships, the capsule appears as a flaming fireball as it streaks back into the atmosphere. Patrol aircraft fly to the impact area and pick up the capsule's recovery signals. 2 destroyers race to the area. The Navy ship Strong makes the pickup. The capsule survives its re-entry in excellent condition. Other areas of the space program are successful in 1959. By August, 10 of the 17 launches are good. The NASA teams are now facing the future with confidence.
Retard your speed to 1/2.
What was that?
I don't know.
Well, Telecane ship coming up fast behind us.
Since the likes of Buck Rogers and Flash Gordon first streaked across the universe in their bullet-shaped rocket ships, few figures have captured public imagination as has the astronaut. That intrepid spacefaring explorer. Yesterday's pioneer pursuing new frontiers in the flying machines of tomorrow. In 1959, 7 larger-than-life men brought the hero of the Saturday matinee to life, and with it renewed the American spirit of exploration. The face of space travel has changed dramatically since the days of Mercury 7. But one thing that hasn't changed is the tremendous time and effort put forward by the dedicated men and women who reach for the stars. The long journey to space begins here at NASA's Johnson Space Center, where thousands of applicants from all walks of life will be reduced to a select few. Selection, however, is only the first step to the launch pad. A grueling ordeal still waits these astronaut candidates. After a year of intensive basic training, those who've shown that they have the right stuff are rewarded with the coveted wings of an astronaut. But the hard work doesn't end there. In fact, it's just beginning. Now eligible for assignments to new shuttle missions, the new astronauts turn their attention to learning even more about their roles in the Space Shuttle program. Training is essential. Imagine not driving a car for a year and then being called on to drive in the Indy 500. It may sound ridiculous, but astronaut pilots face a similar task if they've not flown recently, and then are expected to pilot the shuttle to a safe landing. The Norther T-38 enables the pilots to maintain their flying proficiency, but it's a specially modified corporate jet called the Shuttle Training Aircraft, or STA, that introduces them to the unique aerodynamic characteristics of the orbiter. In addition to these aircraft, the pilots also train in the Shuttle Mission Simulator for an added touch of realism. Mission specialist astronauts also have elaborate tools to help them train for their tasks. On computer-based single-system trainers, they're able to learn the orbiter's sophisticated systems in an individual setting. At the Manipulator Development Facility, mission specialists practice with the shuttle's mechanical arm. Inflatables are used to simulate microgravity for such tasks as the retrieval of errant satellites. And for those tasks that require hands-on attention, the Weightless Environmental Training Facility provides a watery simulation for working in the microgravity of space. Two less sophisticated trainers are used by pilots and mission specialists alike to practice other vital aspects of space travel. The full fuselage trainer is a full-scale mock-up where crews get a feel for living and working in a real orbiter. Its payload bay can accommodate a full-size Space Lab mock-up. Close by is the crew compartment trainer, a full-scale mock-up of just the orbiter's crew compartment. It can even be tilted upright to simulate the crew's takeoff position on the launch pad. In spite of all the trainers, simulators and aircraft, the life of an astronaut is not all training. They also perform a variety of other duties that contribute to the overall team concept of what has become a trademark of the astronaut corps. For example, in the Shuttle Avionics Integration Lab, astronauts blend their own unique perspective to the development and testing of complex avionics software. They also play a major role in payload planning, working with the scientists to make sure that payload expectations don't exceed the shuttle's capabilities. Cape Crusaders are astronauts that track orbiter processing at the Kennedy Space Center and provide launch assistance. But perhaps one of the most visible signs of astronaut teamwork is the role played by the Capcom during an actual shuttle mission. This mission control position, filled only by fellow astronauts, is responsible for air-to-ground communication while the shuttle is flying. Another aspect of astronaut life are the personal appearances they make, helping to make the manned space program a little closer to all. Now that we've seen some of the things that astronauts do when they're not in space, let's see what they do when they are flying. The odyssey of a mission aboard the shuttle begins about a year before launch, when individual astronauts are assigned to a crew for a specific flight. From then on, it's non-stop preparation all the way to the launch pad. Finally, the moment they've waited a lifetime for arrives.
10, 9, 8, 7, 6.
At T-minus 6 seconds, the orbiter's 3 main engines ignite, unleashing enough thrust to power 7.5 747 jumbo jets. Powerful turbopumps begin flowing fuel to the engines at a rate that would empty an Olympic swimming pool in 25 seconds. The main engines are soon joined by the solid rocket boosters, adding a further 44 million horsepower. And by the time the shuttle clears the tower, it's already traveling at more than 100 miles per hour. As it accelerates up the hill, it's generating more power than 23 Hoover dams. In a matter of minutes, the shuttle and its crew of astronauts will be in space. Once in orbit, the long months of preparation are put to use in workdays that average as many as 16 hours. Hours filled with scientific experiments, medical research, environmental and atmospheric studies, and the list goes on. Some crews will deploy multi-million-dollar satellites, while others may leave the spacecraft to rescue one. There are also more mundane chores to perform, such as housekeeping and meal preparation. But the time in space is not all work. There's also time for the unique recreational opportunities found only in space. Or to just take in the spectacular beauty of the moment. There's no denying that a ride on the shuttle is the best seat in the house. But what goes up must come down, and the same is true of the shuttle. After a journey of more than 1 million miles, each astronaut returns to Earth with unforgettable memories and already looking forward to his or her next trip into space. Yes, today's astronauts are a far cry from Buck Rogers and Flash Gordon, but through their adventure, the dream of reaching for the stars lives on. That brings us to the end of this edition. We look forward to your company next time. But remember, we are out there. What we can and can't see is out there, and the mysteries between us, although seemingly insurmountable, are encompassed by a disappearing frontier.